Despite its thin atmosphere, Mars has a variety of clouds floating in its chilly air. Martian clouds can be composed of water, carbon dioxide, or dust, and some of the clouds are similar to earthly clouds while others are unique to Mars. One such phenomena are the beautiful cloud streets, linear rows of fleecy clouds that develop around volcanoes in the Tharsis region near the equator and the vast northern lowlands in spring and summer. While they resemble cumulus clouds on Earth, they are formed under different atmospheric conditions. Mars also gets impressive dust clouds that can spread hundreds of kilometers, a phenomena we don't experience on Earth. When Curiosity rover was looking for rock targets to collect samples from, it did some mini drill tests on the rocks seen here. The test was done to assess whether the rock was appropriate for full-depth drilling to collect a sample. The drill cut a hole about 1.6 centimeters in diameter, and the hole from the shallow drilling test is near the top of this image. The test drilling cracked the target rock and dislodged pieces of it. A few hours after seeing the results of this test, the rover team decided that an alternate target location in this area would make an appropriate site for sample collection drilling. However, they did some close-up investigation of the resulting rock fragments with freshly exposed surfaces, particularly the grayish one on the right-hand side of the image. This view shows the Yellowknife Bay, which is a 5-meter geologic depression located in the large impact crater known as Gale crater. The site was studied by Curiosity rover to assess whether the area ever offered habitable environment for microbial life. The site was chosen after previous observations showed morphological features created by the presence of liquid water, suggesting the presence of an ancient lake which could have sustained life. Previous observations have shown that the strata exposed here are most likely to be fluvial lacustrine deposits. These aqueous environments are believed to preserve evidence of paleohabitability and potentially Earth-like microorganisms capable of breaking down rocks and minerals for energy, known as chemolithoautotrophs. Curiosity also used its ChemCam and MastCam instruments to analyze the chemistry and layering of a geological outcrop designated as Shaler. This geologic formation displayed cross-bedding features which showed clear indicators of past interactions with water flows. The rover also collected rock samples by drilling into mudstone sedimentary rocks at 2 locations. The analysis of the samples showed a large amount of phyllosilicates, clay minerals such as smectite, to be major constituents in the 2 samples. Since clay minerals are hydrous aluminum phyllosilicates and form only in the presence of water, this further supports the claim that an ancient crater lake once existed in this region. Other silicates were detected here as well, such as the magnesium-rich end member of olivine called forsterite, pigeonite, plagioclase, augite, clinopyroxene, and orthopyroxene. These detected minerals are all indicative of a potential mafic source for the origin of the deposition. Many dunes and ripples on Mars are active, which demonstrates that in some areas sand is loose enough and wind strong enough that significant change can occur. Nevertheless, other Martian dunes are clearly inactive. This image in Arcadia Planitia shows dunes in a crater. Unlike active dunes on the planet, those here are bright, and zooming in there are several lines of evidence indicating that the dunes have become indurated, that is, hardened into cohesive sediment or even into sandstone rock. For example, the dune field at the southern edge is cut off by a steep cliff, indicating erosion of hard material. Although fine-scale ripples on the original dune surface are preserved, we also see large-scale fluting from southwest to northeast, a common texture associated with wind-induced sand abrasion. How these dunes became indurated is unknown. One possibility is that this area of Mars was buried and then exhumed, a process that seems to have occurred many times in the Martian past over various areas of the planet. During burial, compaction and possibly groundwater circulation would have indurated the dunes, leaving them as hard sandstone that when exhumed was subsequently partially eroded.